In a world where high-performance, zero-defect buildings are hard to find, two men are on a mission to disrupt the status quo. Welcome to the Edifice Complex, the property design and development podcast. Let your hosts Adam Muggleton and Robert Bean keep you up with who is innovating and doing great work, perspective on the adjacent possible, and challenges to the status quo.
Welcome to the Edifice Complex. I'm Robert Bean, your co-host and unofficial mediator, here with my colleague, official agitator, friend, and Yoda of most everything to do with buildings, Mr. Adam Muggleton. Say hello, Yoda.
Hello, Yoda.
Listen, today's guest is one of the green building and real estate industry's foremost thinkers and strategists, and certainly an advocate for sustainable design solutions at all levels of business, government, and civil society. His expertise has been sought out by organizations as diverse as Fortune 500 companies, leading universities, nonprofit organizations, and the U.S. military and foreign governments. He has been endorsed on LinkedIn by some real heavyweights, some of our past interviewees. Jerry Udelson certainly is one of them. Peter Rumsey, who we want to get on, right, Yoda?
Absolutely.
And also Drew Colley, who I know through the ASHRAE organization, among many, many other heavy hitters. I was fortunate to hear our guest give a lecture at the 50th anniversary of NeoCon, which is one of the biggest interior design shows in North America. And I ran into a colleague recently in Italy, an architect in Italy who had also worked with our guest and, of course, knows of him quite well. So I want to introduce you to Mr. Bill Browning. Bill, welcome to the show.
Hey, how are you guys?
Very good.
Doing good. Bill, you are a founding partner with Terrapin Bright Green, which develops environmental strategies for governments, corporations, and real estate projects. And amongst your many, many accomplishments, you're the founder of Green Building Development Services while you're with the Rocky Mountain Institute, which is a cool story. You're a graduate from the Massachusetts Institute of Technology. I think you have a master's degree in real estate development. I think I'm correct me if I'm wrong there. And also University of Colorado Boulder, environmental design. And amongst your other accolades, you received the ASID, which is the American Society of Interior Designers Design for Humanity Award. You have a very influential publication out there called The Economics of Biophilia, Why Designing with Nature in Mind Makes Financial Sense. Bill, we always ask our high achievers to tell us their story. So what's yours?
Military kid, grew up watching Jacques Cousteau, got inspired about the environment. So eventually decided I thought I was going to be an architect and went off to design school to study town planning, landscape architecture, and architecture. Got out and went to work for John Denver's WinStar Foundation, building Buckminster Fuller's last building, a spherical greenhouse that was 25 feet in diameter and could grow all the fish and veggies for a family of 4 at 8,000 feet in the Rockies, driven by sun.
That is cool, I have to say. Just got to put that out there. That's amazing. I like that.
Didn't Buckminster say something about design that when design is completed, if it's not beautiful, it's not complete?
Yeah.
Was that something? He had said something about that, and that always stuck with me because, Adam, we had Holly Chanton from the United Arab Emirates. And she gave us one of those gems about designs, and from an engineering perspective, that engineering design in of itself can be beautiful.
Yeah, absolutely.
So
Fuller also is an inspiration for a fair amount of our work in biomimicry, innovation inspired by nature, where he had this great comment where Bucky said, "I'm not trying to replicate nature. I'm trying to figure out the principles that she uses."
Oh, I like that. I like that. Almost, you could see some Steve Jobs inspiration in that, right? About the respect and the absolute devotion to design outcome.
Yeah, absolutely.
Right? There's a bit of that in him there. Did you actually meet the guy?
Mm-hmm. Yeah, I met him several times. I was supposed to spend a summer working with him in 1983, and about a week and a half before he was coming out to be on site with us, he died. But we went ahead and finished the project and got it built. And the last few years, I've been on the board of the Buckminster Fuller Institute.
Wow, that's really impressive. That's sort of like so degrees of separation, right? I now have 1 degree of separation between me and Mr. Fuller. That's a crazy. That's amazing.
Yeah.
I don't think people understand how influential he was as a design figure, right? And as someone who was trying to push technology as a solution to mankind's growth. Can you speak a little bit about him?
He basically said we need to come up with solutions that work for everybody in all time.
Yeah.
And that we won't succeed unless we focus on doing the right thing for everybody, not just people, everybody. And so everyone thinks of him as a technologist, but in many ways I would put him in a different category of humanist and really thinking about what's best for the long term of humanity and the rest of the planet.
Yeah, well said. Well said.
So really a leading voice in the whole concept of sustainability. Like if you think about the philosophy of sustainability, doing the right thing for everybody is a nice marriage with that philosophy.
Yeah, definitely. And so the connection there was with John Denver, the musician, working for his foundation. And John was an architecture student who dropped out of school to be a full-time musician. But he always kept a passion for design, and he was one of the patrons. He's one of the folks who financially kept Bucky afloat for the last years of Bucky's life.
Oh, interesting.
That's it. Yeah. That's really interesting. So in a way, he's almost the godfather, not the father, the godfather of the sustainable design movement in a way?
Fuller, he would be one of the major influences, and you'll see that a number of the early pioneers like Bob Berkebile and others who started the AIA Committee on the Environment had worked with Bucky and were heavily influenced by Bucky's thinking and work as well.
If he was alive today, what do you think his observations would be on the world of property development and architecture?
Mixed. Some of the things he worked on have come to fruition, others have not. But I think he'd be amazed by particularly where computers and electronics have gone. He's the one who really was pushing the concept of more with less.
Right.
And we definitely have achieved that in some parts of the world and with some technologies. Others, not so much. We still need to do some work on that. But there's, it's one of the reasons why for us biomimicry is intriguing, because nature's got 3.8 billion years of experimentation out there that we need to be learning from.
Yeah, that's a lot of R&D.
Yeah. So you really haven't gone into sort of you have such an interesting story, and I appreciate you giving us the Coles notes on it. But maybe we should continue on, and that is that a lot of our audience probably have never heard the word biomimicry or biophilia design. So why don't you give them a brief 101 what that is all about?
So in a lot of Terrapin's work is really in two fields of research. One is biomimicry, literally innovation inspired by nature. And that work, the sort of piece that most people know from that is the book that Janine Benyus, wildlife biologist, wrote, literally called Biomimicry. And it's asking, how do we not grow more things or GMO a critter to do something? It's actually, how does nature do that? And can we learn from the way that nature solves that problem? So Terrapin ran for 5 years a program for the state of New York, for the New York State Energy Research and Energy Research Development Authority, NYSERDA, that was working with companies to investigate how to solve design problems that conventional engineering had not solved. One of our favorite examples, a company they work with, is called Harbeck. And Harbeck is an injection molding company, and they are making very complex parts that had to be structurally sound and not have flaws in them. So when you're doing injection molding, you have two metal molds that come together, and you put hot plastic into there, and then you cool off the mold by running fluid through it, and then open it up and take the piece out. And if you did it too fast or didn't do it evenly, then the structural integrity of the part may be in question. So if there was a way to speed that up, you would both save a lot of energy, and you would also mean you could produce more parts in a shorter period of time. And so what we looked at with them was the way that you run the fluid through the mold is largely almost guesswork in some cases. And frequently you just have 2 holes drilled through the mold and you run the fluid through there. So instead, we got into a new field of science started by a mechanical engineer at Georgia Tech, a guy named Adrian Vijan. It's called constructal theory. And it comes from the observation that if you look at the capillaries and veins in your hand, or the pattern of veins in a maple leaf, or the channels of water in a river delta, and you look at those pictures, ever notice they look like the same thing?
Yeah.
Right?
Yeah.
So what that is telling you is the optimal flow pattern for that 3-dimensional space shape. And using a new branch of mathematics called Murray's Law, I can design that out and do the mathematics of how big those channels are and how long those channels are to connect them together. And so a simplified version of that you see frequently in plant leaves is you'll have 2 channels and then interlacing channels with those. It's called a dicot pattern. So putting a dicot pattern into the walls of that mold, and then now you have a mold that you're not drilling the holes through. You actually have to laser sinter, 3D print the mold in metal.
Sure.
Right.
Which makes the mold a little bit more expensive, but the net result is that you cut the energy use by 23%, and you cut the cycle time per 100,000 parts by more than 20%.
And that compounds over the lifetime of the run, of the production, right?
Exactly.
Yeah.
Exactly. Huge economic gain.
God, that triggered so many thoughts when you were telling me that. So I started thinking about radiant heating, radiant cooling applications for that, for houses and offices. And
Right.
Well, when we do our instruction on thermal comfort and we get into human physiology, the arteries and the veins in the human body are the transport mechanism for that heat flow. So this, Bill, your comment, and one of the things that came to my mind, Adam, was, the Earth is a great big heat exchanger.
yes.
And, millions and millions of years it's taken to evolve to where it's effective at what it does. And cycle times, 24 hours a day.
Yeah.
In 24 hours a day, we both heat and cool the Earth. So
I'm going to loop you back to that thing on human heating and cooling, because in our related field of biophilia, human connection to nature, one of the areas we have been doing work on is thermal perception and variability. And in particular, we really are inspired by the work of Gail Brager at University of California and
Berkeley. Yeah.
In Berkeley, in the field called alesthesia, and how thermal differences, both temporally and distance-wise across the body, are perceived. And one of the things they've really learned, she and others have learned, that if I really want to cool someone down, I'm going to cool down their wrists, the underside of their wrist, because those are the veins that go most directly back into the heart. And so that's why you see the Army doing gloves that heat or cool people literally by heating or cooling on that. Or desk design where you put a chilled bar right at the edge of the desk that you can just put your wrists on and cool down that way without having to change the air temperature or any of that other stuff.
Yeah.
And so, but that's playing around then with constructal theory. Where's the optimal transport and distance?
Yeah. That whole concept of alesthesia, but the flip side of that is homeostasis. And so if you think about I don't know if you guys remember Weebles wobble, but they don't fall down.
Oh, yes, I'm of that age group.
Yeah.
Right. So if you can picture one of the Weebles and it's in a stable form, that's the body's homeostatic state. Alesthesia is like pushing the Weeble over to exercise its balance mechanisms. And so one of the challenges, and I know Gail through our work through ASHRAE Standard 55, and one of the challenges that the proponents of alesthesia, and even those that are not proponents, is how much is too much? How far do you let environments change where the resulting stress becomes a health issue as opposed to an exercise of the body's human thermal response systems? And that to me is where the challenge is right now.
Yeah, we're still learning that. I mean, but if you look at, for instance, the performance of school children in classrooms with thermal variability, work that Ihab Elazadeh has done at the University of Oregon is if there's a substantial amount of thermal variability within an individual classroom, those kids do about 15% better on test performance.
Yeah.
That's an interest. Now that is a very interesting outcome, right? Because that's an outcome-based phenomenon.
Right. I mean, another thing is, if you're in a big conference room in Japan, and I actually had this experience, I'm standing in the middle of this big conference room preparing for a presentation, and suddenly a breeze comes through the space, and I thought, oh, how nice, someone has opened a door. And no one had opened a door. Actually, the mechanical system was designed to do that, to keep you alert and awake. And it just happens randomly. It's ramp up the mechanical system, and off you go.
That's interesting and very Japanese. Yeah. I've got a project in Japan next year. I'm going to watch out for that. But that's going back to the school example, right? So, there's so many things horrible about schools, the curriculum, the way it's all taught, but also the environment, right? You're putting the kids in. I mean, in my experience, certainly in my experience in Canada, school design and construction is about as low end as it could possibly be, right? There's no innovation there. There's no thought for how that might affect the kids in their performance or outcome at all. I just wondering how you could take that idea of, radiant systems lead to better outcomes, right? Less air being squirted around, more even thermal comfort. How do you take that into a school board and sell that? I don't know. Well,
first of all, I probably don't want uniform thermal conditions throughout a classroom. No. That's one of the things we've learned. Similarly, we don't want uniform light conditions throughout a classroom either. We as a species did not evolve in a condition with uniform light or uniform thermal. And so we want some variability on both light and temperature. The work that we're seeing around biophilia, human connection to nature, is one of the places where we can really look at performance in classrooms. And that comes through in a variety of different ways of connecting people with nature. Thermal and light are two of them. Obviously, a view to nature is incredibly beneficial. And we had a period in North America, particularly in the early 1970s, where we had lots and lots of schools designed with no windows. And the idea being that windows were distracting. What we now know through work done on what's called attention restoration theory is that if I can get you to look up and look away at nature, it changes the way the brain is processing. Prefrontal cortex quiets down briefly, and then when it gets reactivated, I have better cognitive capacity, significantly better cognitive capacity. And so that's called attention restoration theory. And the question has been, how long do I need to look out and look away at nature to have that to happen? And work done at the University of Melbourne, published a couple of years ago, indicated that all it takes is 40 seconds.
Wow.
Yeah. So, Bill, have you worked with ANFA, the Academy for Neuroscience and for Architecture?
Yeah, I did a presentation at the conference this year.
Yeah.
On the science of biophilia and overlap with neuroscience. We've got two things going right now. One is we're fundraising for an experiment with the Cloud Lab at Columbia University on an exercise called neurocartography. But before I do that, maybe I should loop back a little bit and talk a little bit more about the basis of biophilia before we jump into the geeking out on that part of the science.
Okay, yeah, that'd be great.
Yeah.
So biophilia is literally bios and philia, life and love of. It comes from the social psychologist Erich Fromm, that got popularized by Harvard biologist E.O. Wilson. And it really is, how does experiences of nature impact us physiologically and psychologically? And more work is really shifting over recently into neurological experience as well, or the neuroscience. What we found in collecting hundreds and hundreds of research papers and working with researchers and all of that was we discovered that we could categorize those experiences of nature into sort of three big buckets. The first one we call nature in the space, and these are direct experiences of nature in the built environment. Things like a view to living nature, plants, animals, water, having water in the space, having thermal variability, having light variability. These are all experiences of nature that you can have in the built environment. The next category are what we call natural analogs. And these are indirect experiences of nature. And so these are things like the use of natural materials, the use of biomorphic forms, the use of fractal patterns, all elicit a very interesting brain physiological response. And then the third category is the nature of the space. And these are three-dimensional experiences that elicit very distinct responses. There are four that are relatively well known. The first one is prospect, and this is an unimpeded view through space. It's really important for wayfinding and a sense of security. The opposite, or the couplet with that, is refuge, where my back is protected and I have a canopy overhead. And so a classic example of prospect and refuge together would be a beautiful craftsman bungalow with that big porch on the big overhanging porch on the front. So you are sitting on that porch. You are about 18 inches, a half meter up from the ground plane. So you have a bigger cone of vision. You can see up and down the street. You have great prospect. Your back is protected by the wall, and you've got the overhang over the top of you. And so you've got a great refuge space. So there you have prospect and refuge together. The second condition is mystery, where there's partially revealed information and you feel compelled to go explore. So if you've ever taken kids or a dog for a walk out in a park and there's a curving path, they bolt and go running around to see what's around that corner, and you got to go chasing after them. Neuroscientists say with a strong mystery condition, you feel compelled to go experience that. Now, bakeries are really good doing that with scent. Walking down the street, you smell those cookies and you just got to go see what's there. Right? Risk peril. This is a pattern you probably don't want to use too much of. It elicits a strong dopamine or pleasure response in the brain. And it's where there is possible danger, but a safety factor. And so a classic example was, if anyone's ever been to Frank Lloyd Wright's Guggenheim Museum and that amazing ramp that leads up through the center of the building, you get to the top and the rail there is just a bit low. Not enough that you're going to fall over it, but enough that when you look over it, you get this exhilarating sense. And it's very funny to see people standing with their hands on the rail and their feet well back from the edge, looking over the edge, right?
So is that a deliberate design choice then? Is that what you're saying?
Absolutely. Absolutely. Wright was very good at using risk peril, and he did it frequently.
It'd be like glass floors and high-rise towers, right?
Yeah, exactly. Yeah. No. So risk peril. So we've developed a pattern language, about 14 different experiences that you can then use in the built environment. And what we've learned about them is that different ones elicit different responses. Some of them help with stress reduction. Others of them help with improved cognitive function. And then others help with mood or preference in the space. So let's go back to that cognitive function in classroom, right? So if I've got attention restoration, that means that I've got a capability of improving the cognitive function of folks in an office building or in a classroom. So I'll give you an example that in an office setting where we actually have direct numbers for productivity, which are hard to come with in office settings, a call center for a utility company. Now, think about it. In a call center in a utility company, people who are calling you probably aren't entirely happy, right? There's a problem with their bill, their power is off, right?
Yeah.
But it's one of the few office tasks where you can actually have numbers of number of calls handled per hour. And so in this call center, which was a LEED gold building with great daylighting, good indoor air quality, raised floor, displacement ventilation, each workstation had its own vent that people could adjust. So good thermal performance, and all these desks lined up perpendicular to the window. It was on the second floor. There were trees and a field outside, but because you're sitting perpendicular to the window, the you're staring at your computer screen answering the calls, you're not seeing the view out the window, not even in your peripheral vision. So spend about $1,000 and move all of those workstations, $1,000 per workstation, 11 degrees off a perpendicular.
Just 11 degrees?
That's it. And what happens is now the view out the window is, the edge of it is in your peripheral vision. And we are hardwired to respond to movement in our peripheral vision, right?
Yeah.
I mean, which lion eats you? The one sitting directly in front of you, the one jumping out of the grass from your side,
yeah.
Right? So, of course, we are hardwired to respond to that much quicker. So if the leaves outside the window start to move, or a bird flies past, or a butterfly, that's going to get your attention and get you to look up and look away. And if I can get you to look up and look away for 40 seconds, now I reset your brain, quiet down the prefrontal cortex, give you that pause, give you that break, give you that reset. And then when you look up and are focused again, you have much better cognitive capacity.
Hey, Bill, does that apply to lawyers, politicians, and tax folks?
I'd say they were all raised in 1970s school buildings.
If you want to see them coming, just turn your desk 11 degrees.
But the result for that call center was a 6% increase in call handling capacity. That was a return of about $3,000 per desk.
Bloody hell. I mean, 11 degrees is not a lot when you think about it. It's not a lot. That is insane. So, all right. I guess there is take the example you just gave of the call center, right? So there's a successful project there by any measure, right? Why is that not scaled up, or how is that kept a secret to some degree, right? Because, you'd think if a call center had that level of productivity increase and ROI, you would think that would go viral at some point, a solution like that.
Well, it's one of the reasons why you see so many of the big corporations, particularly the tech companies, really, really doing a lot of work around biophilia in their spaces.
Yeah.
And for them, some of it is just employee attraction or retention, but it's also looking at stress reduction and cognitive function among their employees. And so this is why Google and Facebook and Genentech and others have done buildings with really strong biophilic design measures.
Yeah, no, you're right. I mean, some of these guys. Sorry, Rob. Just one thing. So, taking the Apple campus as an example of someone with a bottomless pit of money, and probably any design professional in the world would work for them. Would you say the new campus, the circular campus, is a good example of biophilia?
I haven't experienced the building itself, but the really extensive landscaping and the landscaping they created inside the donut and outside the donut, and the attempt to have direct views in and out, I think is probably a pretty strong component of that. If you look at the major Facebook building, there's a several acre garden with walking paths and all that on the roof of that building. So, and Google has a whole set of biophilic design standards that we were part of the team to create for them. And so, we're seeing it there. We see it in other fields as well. We did research on, does the presence of biophilic design change the guest experience in hotels and the economic performance of hotels? And the answer is yes and yes. I mean, one of the things we did was an observational study of 6 hotels in Midtown Manhattan, 3 that were just plain standard vanilla lobbies, and 3 of which had strong biophilic design features. So use of natural materials, use of fractals, use of plants, prospect and refuge spaces created within them. And what we discovered was the ratio between people who were just transitory and people who actually were spending time in the lobby. There was a 36% increase in the people who were actually spending time in the lobby that had biophilic design features. Now, that means that's a 30% chance that they're going to buy a drink.
Yes.
They're going to have some coffee. They're going to have a snack. They're going to increase your revenue, your TRevPAR, total room revenue per room, without selling another bed. Oh, nice. Something that makes hoteliers very happy.
Yeah.
Yeah. Well, Adam and I, and Bill, I'm sure yourself, we spend a lot of time in airports and hotels and whatnot. And where I'm going with this is that I don't sleep. If I get 4 hours a night sleep, I'm lucky. And when I'm in a hotel room, I get even less. And as my sleep hygienist has pointed out that, and actually, Adam, I think Joe Rogan talked about this. He had a sleep specialist on, and he was saying people that travel a lot put their minds into places that they're not familiar with. And our primitive mind has a part of it that doesn't shut down due to risk.
Yes.
In other words, if you're back thousands of years ago and you're out foraging and you spend a night someplace, going back, Bill, to what you were talking about, prospect, refugee, mystery, risk, peril, your body and mind is in a strange place. And of course, you're worried about the lion, the tiger, whatever. And so that part of your brain doesn't shut down. Now, I know when I'm in a good hotel that has good design, it speaks to my sound, my thermal experiences, my visual experiences, that I do sleep better. I feel more safe, more comfortable, and I'm able to relax. And that, to me, that has no price. For me, I would pay a lot of money to have that in a hotel. And I do. I do go to hotels who do cater to my needs in terms of speaking to that part of me.
So you just made the Westin Hotel brand very, very happy, because we just spent the last year redesigning the room prototype to focus on biophilic design. And so the head of the bed is set up in a refuge condition.
Yes.
They have light variability. They're looking and playing around with circadian lighting so that the lighting matches what you need for that time of day, and use of natural materials. And so to try and overcome some of that, they were famous for the heavenly bed. Well, now they're taking that concept to a whole room level.
You know what? Yeah. I saw that prototype and I wondered to myself, why is that bed at an angle? Now I know. That's crazy. So I've got a question. Is there not an intersection here with the Chinese art, let's call it, of feng shui, where that's about refuge in a way? It's about the things we spoke about, right? Refuge, line of sight, and the comfort that's sort of built into our lizard brain about all these things.
Yeah, I mean, if you peel away the layers of mysticism applied to a lot of the geomancy systems, what you'll find are some pretty strong fundamental insights about how people respond to space or climatic response. You have to be careful about, particularly the climatic responses, of translating those to other parts of the world that have different climates. But some of the spatial concepts about how people respond to space are in many cases, fundamentally sound. But you have to kind of cut through layers of mysticism to get to that. But you'll find at the base of those some pretty good insights about how people respond to space.
So this draws me to the word, and I might get this wrong, but salugenesis, where environments are healing. And I think that was a term coined by Aaron Anatoski, I think it was the guy that came up with that. But the whole premise is that rather than the medical industry responding to people who are sick, that's prevent them from getting sick through environmental design processes, which is sort of falls in line with the Academy for Neuroscience for Architecture. And Bill, what you're doing with biophilia and biomimicry. Adam, you asked the question, and that is that why is this whole philosophy and principle not mainstream? Like, are they teaching this in architectural programs and engineering programs too? Because the principles apply to both in engineering and interior design and in architecture. Why don't we not see this more?
So we are starting to see in some interior design and architectural programs some level of biophilia being taught here and there. The American Society of Interior Designers' new headquarters is a really strong exercise in biophilic design, an explicit exercise in biophilic design in which they did really in-depth studies of how their staff responded to that space after they moved in and over the year plus that they've been in that space. So we're seeing some shifts here and there. And I think as we see more and more of the neuroscience evidence and understanding some of the mechanisms, I think it'll get stronger as well. So, one of the things we've been fundraising for is an experiment with the Cloud Lab at Columbia University, an exercise called neural cartography. And this is going back to our hotel lobby study where we wire people up with mobile EEG units that are geo-tracked. And so as you move through space and your brain state changes, the pixels on the map underneath you change colors. And so we'll take a whole bunch of people, different demographics, different weather conditions through this experience and then start layering the maps on top of each other. And if we see consistent color patterns emerging in different spaces, with the wide range of demographics, weather conditions, and other times of day, if we see a consistent pattern, that's a pretty good indication the space itself is inducing that response.
So this is interesting because I have a little bit of knowledge about QEEGs, which brain mapping is one way you look at that. And one of the challenges that the neuroscientists have with the QEEGs is there is a normal brain. In other words, if you took a database of 1,000 brain signatures, some of them would exhibit what would be called a normal brain. But then you have signatures of people who have, say, for example, attention deficit disorder or schizophrenia, or they're drug addicts. They've got the brain of a coke addict or that type of stuff. So, but one of my hypotheses is that we should be able to use these brain sciences to establish in a good brain what is a good environment. The brain will respond to what it sees, feels, hears, touches, all of that. And so if we get it right, then we should see consistency in the brain signatures. And at that point, we should be able to define what is a stressful environment and what is not a stressful environment. So let's take your brain, Bill. Let's say you have a normal brain.
I'd say it was quite big, actually.
Let's say you had a normal brain. We put you into an environment. We put a QEEG system on you, and we get a baseline so that the lighting, the sound, the thermal environment, the visual environment is one that's pleasing to your brain. And then that starts to play around by increasing the sounds. That makes the sounds annoying. How does the brain signature change? Let's change the light. Let's change the thermal. And we should be able to see how your brain responds to those changes. I think
that would be nice. The equipment's not quite ready for all of that yet, but we are moving in that direction pretty quickly.
Yeah.
One of the things that we are seeing, a lot of the experiments are using fMRI, functional MRIs, and so seeing the changes in blood flow indicate which portions of the brain are being stimulated. And so a fair amount of the visual processing work and some of the other, like the attention restoration 40-second study, was done using fMRI. There's some new work coming out of, that'll hopefully be published in the next month or so, out of Aalborg in Denmark, where they were looking at a branch of science, understanding how people respond to space, called affordance theory. And that's a non-conscious response to objects and knowing what you can do with them or what behavior happens in that space. So if I show you a picture of a chair that you've never seen before, you don't have to think that, I can sit in that. You already know it, right? Brain tells you, through, and you can mimic the action of sitting in that chair through the mirroring neurons in the brain. And so an experiment that was run at Aalborg that hopefully we'll see published very soon looked at options of whether you could or could not go through a door. And what they discovered was that the decision to go through the door, not go through the door, whether or not if the door was red, it wouldn't open. If it was green, it would open. That happened in that mirroring neuron process in the brain so fast that it was clearly a non-conscious decision. And so that's using a very advanced form of EEG that takes out the theta signals from moving your head, the muscular and things like that.
Right.
So we're starting to see some of that emerge and an understanding of how we get to responses in space. So Biophilic is evolving, continually evolving. We're working on some new patterns, new responses, and we're also still in the process of collecting case studies because we're working on a new book on experiences of and responses to biophilically designed interiors. And so the working title is called Nature Inside, to be published by the Royal Institute of British Architects in 2020.
The Edifice Complex will continue in just a moment. If you're enjoying this podcast, we need your help. We're not asking for money, just a minute of your time. Our goal is to make the Edifice Complex podcast as relevant, educational, and useful as possible. By having good ratings, we can reach the widest audience. Therefore, our request is two small things. If you haven't already, leave us a review and rating on iTunes. And subscribe to the Edifice Complex on YouTube, even if you normally only listen to the audio version. These two things will help us immensely. Also, if you would like Robert or Adam to speak, teach, or consult on your project or business, please email admin@edificecomplexpodcast.com. Thanks for your time, and now back to the show.
Yeah. So the other topic we were on earlier was biomimicry, which is one of the other things we do a lot of work in. And in particular, we've been increasingly interested in doing more and more work on biomimicry at an ecosystem scale. And so, not just looking at an individual critter or an individual thing, but asking, what is this place doing? And that came out of a couple experiences. One was a client of ours had a building in the lower portion of the Chelsea neighborhood in Manhattan, a massive building. It was essentially the size of the Empire State Building if it was laying on its side. So it literally covers a Manhattan city block sidewalk to sidewalk, same volume as the Empire State Building, but only 16 stories high. It was built as a warehouse building by the New York, New Jersey Port Authority. Trucks came into the building and were put on elevators and taken up and down through the building, and then drove around inside the building to make deliveries. And there were 4 of these elevators. 2 of them are still operational. Our client bought this building in the late 80s, early 90s. It was essentially more or less abandoned in a not so great neighborhood at the time, but it happened to be where fiber was coming onto the island. And so they started leasing space out, and they leased out 1 million square feet to data centers. Each tenant put their own independent mechanical system on the roof. The roof is sort of a wedding cake, and when you see this rooftop, it is the most amazing museum of every mechanical strategy. You name the system on that roof. So when we got to it, the issue that they had was there was no more space on the roof for additional heat rejection. And so none of the tenants could expand their loads inside the building. So that was problem number one. Now, associated with that was also the biggest energy bill in New York, $53 million of electricity a year.
Wow.
If that wasn't weird enough, they said, oh, and by the way, we've got this other odd thing going on in the building. We purchase 51 million gallons of water a year, and we put 90 million gallons into the sewer.
For a data center.
Data centers and some offices, but yeah.
That doesn't add up.
That kind of bends most of the laws of physics that I know.
Yeah. So condensation, you're saying? Yeah.
Well, even just rainfall is 5 million gallons. But there's still 45 million gallons unaccounted for there, right?
Yeah.
It's not going to get you 45 million gallons.
Yeah.
So what we found in the lowest sub-basement of this building, under the parking decks under the building, 3 huge sump pumps, pumping continuously, pumping clear, fresh water out of the building and into the sewer, which it's been doing since 1930-something. What we discovered going into a project called Manhattan, which remapped the ecosystems of Manhattan back to the point of European contact in 1609. And what we discovered was this was a forested site with a stream that started right in this building, or where this building is.
Oh, cool.
Which has been continuously pumped out of the building and into the sewer. So we asked what else this ecosystem was doing and developed a set of numbers. So 45 million gallons of water flowing through the stream, the biodiversity counts, the energetic flow from sun, the nutrient cycling, and the carbon numbers, the carbon balance. So in 1609, the building site would have been sequestering 3.7 tons of carbon a year. When we ran the numbers several years back, the building had a carbon footprint of 85,000 tons of carbon a year. Now, while we were in the process of doing that research, one of the tenants in the building handed the owners a check for $1.8 billion and bought the building and said to us, "We know you're doing this work. You've been doing other work for us as well. We'd like to really explore this. We love aspirational standards. Saving 30% of the energy is not googly. Our long-term goal should be go from 85,000 tons of carbon a year to minus 3.7.
That's pretty.
So opens up a conversation. It also opens up a conversation about what do we do with that water.
Yeah.
And so moving towards using that water, using rainwater, only using city water for drinking and cooking long term, and putting cisterns in to capture that water and the rainwater and other water will actually eventually return the building to a water balance very similar to what it would have had when it was that stream in that forest. So moving that concept forward to Interface, the carpet company based in Georgia, with B3.8, the Biomimicry folks, and Interface, we've been working on a project called Factory as a Forest. And it comes from the conversation that Ray Anderson, the engineer who started Interface, had with Janine Benyus from Biomimicry, asking a question of, could my factory perform as well as a forest here does? And so in that project with B3.8 and the biology team, looking at an intact example of that local forest system and deriving performance numbers from it. 15 metrics on carbon and nutrient cycling and water balance and biodiversity and atmosphere, putting all those together and having 15 target numbers that then got translated from the ecosystem to a building equivalent. And then you multiply it out, whatever the acreage of the site is or the square footage of your building. So now you have 15 performance numbers to say, can I conceive of a way that my building replicates or restores the ecosystem services that the ecology of this place used to do? So this is taking this idea of regenerative design and moving it beyond just let's have a conversation about process and move it into now I actually have numbers to tell me whether or not I'm getting where I should be going.
Yeah, and you're talking about getting back into balance, right? There's a balance.
I love that.
To be achieved. Ultimately.
It's more than just balance, right? You know, we're not talking net zero energy because nature doesn't do zero.
No.
Right?
I like that. That's the buzzword.
Nature cleans up water. Nature doesn't do zero.
I love that.
Is way more interesting than that. So, yeah, do I need to do net zero energy? Yeah, and then I need to go beyond that because nature doesn't do zero.
I love that. That's cool. I want to take you back for a second to fractals. So they fascinate me, and I have this personal love for symmetry. I think it's to do with my OCD and general craziness. But how do you were speaking about fractals in the hotel lobby design. How are you introducing fractals into hotel lobbies? Is it through the wallpaper design? Or
you can do it through perforated metal screens. You can do it in fabrics. You can do it in wallpaper. Natural material, particularly wood grain, is layered fractals, and it's never the same. Now, you have to be careful with fractals, particularly if you get into doing like fractal iterations, right? So if I take a square and I rotate it away and I create a checkerboard and I've got now 6 squares colored in dark, that's the first iteration. Then I do it again and I do it again. I do it a third time. Now I've got a Coptic cross, right?
Right, yeah.
Or the world's most common cross-stitch pattern. If I do it to a 4th iteration or a 5th iteration, now I create something really spiky and scary. So fractal iterations are a bit of the Goldilocks issue, right? Not enough is boring and too many is scary. And it seems to be somewhere around the 3rd iteration seems to be the preferred iteration of fractals if you're doing them like a Mandelbrot set or a basket. But fractals also occur in natural things as well. You know, the most commonly, think about a snowflake or think about a fern leaf.
Maple leaf, yeah.
Yeah, you got the self-repeating pattern there.
Yeah.
And so one of the neuroscientists we work with says fractals are brain candy. We're really fascinated with them. We don't know why, but we seem to be really fascinated by them.
Yeah, personally, I find symmetry in fractals very soothing.
Well, one of the theories is that when we see fractals or when we see things that conform with like the golden mean and the Fibonacci series in the built environment, because those occur so much in nature, one of the theories is that our brain is already attuned to them. So when we see them in the built environment, it takes less energy for the brain to process that, and therefore it's a pleasurable or no stress response.
Yeah, that makes sense, actually. I get that. All right. So I just want to be on the record saying I'm all in on fractals. So.
It's interesting because it seems a lot of these principles are going to be in conflict with some starchitects that Adam loves to talk about. I don't want to name names because ultimately they might be both of your clients at one time, but one of them, their last name rhymes with scary. And those buildings are so distorted and so out of nature that when you look at them, they're actually hard to look at.
But isn't that the point? To make you notice them, I guess? Is that one of the architectural tricks that's being pulled off there?
Yeah, well, we have done work with him. And, they are, unlike some of the other deconstructivists, very honest that they're sculpting space. Right. Sometimes they're successful and sometimes not so much. I think they're more successful when they're fully sculpting the space as opposed to putting a crumpled aluminum wrapper around a shoebox. When they actually generate buildings that go to form. Zaha Hadid's.
Oh, she's my favorite.
Were, a lot of them were I really disliked, but one of her very last buildings was actually one where the forms were actually derived by shadow patterns and by computational fluid dynamics and air movement and all of that. And that was the energy center in Riyadh. And it's like, why did it take you so long to finally get to that? And why didn't you stick around to do a few more like that? And actually, if you are deriving forms, if you want to see someone who does phenomenally complex forms that are as complex or more complex than Gary's or Hadid's, look at the work of Alan Short. And he's an architect in the UK. And he does buildings that are entirely passively ventilated, and breweries and engineering schools, De Montfort University in Leicester, and performing arts center with multiple theaters and performance spaces next to it, active train line that is just in Manchester. His work produces unbelievably complex forms, but really amazing buildings that are actually ventilated.
Wow, I'll have to check that out.
The whole concept of, and I don't remember who said this, about the shape always existed. You just had to remove that which didn't belong. And if you think about a totem pole, West Coast totem pole, the tree already had the shape there, but the artist took out that which didn't belong, and what was left behind was the shape. And I think that whole philosophy has obviously some applications in architecture, but I think some architects have removed stuff out of shapes that become offensive to the eye. And certainly in the process of developing that shape, they forgot about the people inside. And so what was important was, of course, more to deal with their egos, look at the building I created, and never mind about the people inside or the people that look at it from the outside.
There have been some buildings, and I won't name names, but I know an art museum in the West that people get nauseous in because of the angles in there. There were other folks, there were a couple of deconstructivists who actually wanted to make people agitated in their spaces. And, if you're doing a fun house, great. If you're trying to do a building that people are living in or working in, that's not responsible architecture.
So I just want to quickly talk about...
I like that term, responsible architecture.
Well, yeah, but that's open to interpretation, right? Just a tad. Just want to talk about New York City quickly. I lived there for a year. My two children live there. It's a place close to my heart. But, practicing your particular form of art, engineering, architecture. I think it's a combination of all them things, actually. In a city like New York, which has got an established grid, it's a concrete jungle by many measures, right? How do you apply that in a city like that? Now, it's interesting here you talk about the Chelsea warehouse, but that sounded like a pretty unique situation. What about generally the built environment, for offices and all the other hotels and all the other things that are going on in New York?
Yeah, so some of that comes down to how you are creating the form of the spaces inside, your choices of materials, how you're bringing light and air through the building. Are you bringing life into the building if possible? We, with our sister firm, Cook Box Architects, put in one of the first green roofs in Manhattan in our old office that we used to share together.
Right.
And that was, pretty extraordinary. Now you're seeing green roofs all over Manhattan.
Yeah.
And this whole movement to occupy roof space, rather than giving it over all to mechanical systems, let's really look at how we put both up there, people, and create some habitat there. The entire rooftop commercial agriculture. There are companies like Brooklyn Grange that actually farm rooftops in New York City. The success of the High Line is extraordinary. Right?
I love the High Line. That is brilliant. So for people who don't know, that's an old train line that's above ground, elevated, and it's open to the air, and it's been repurposed into a walkway, a public walkway with lots of wildlife, lots of artifacts, lots of everything. It's just a brilliantly well executed and delivered concept, in my opinion.
It gets 3.8 million visitors a year.
And for free, right? Last time I walked it, there was no charge. Yeah.
And so it's the second, it and the Empire State Building are the two most visited tourist destinations in Manhattan. And it's a pretty extraordinary experience. And we're seeing sort of versions of the High Line crop up all over the place. And there's a group that was founded by the University of Virginia School of Architecture, professor there, Tim Beatley, called the Biophilic Cities Network. And it's now more than 20 cities around the world that are part of this network. And each one is exploring different mechanisms for how do we connect our citizens with nature and experiences of nature in the fabric of the city. And each of those cities then brings what they're doing and shares them with the other cities through the network. And so, Singapore has their own system for recording and measuring biodiversity and the fabric of the city that they've shared with others. Singapore also has the green area ratio mechanism, which is if I'm building a new building in Singapore, I have to, in horizontal surface area on that building, plant more square footage than the footprint of the building.
That is quite a nice metric. I like the simplicity of that requirement.
And so we're seeing buildings that have green area ratios of 3, 4, 5, and more, right? Think about that.
Yeah, that is...
Park that's more than the footprint of the building. We see, like Wellington, New Zealand, has cleaned up the water in the Inner Harbor so much that they actually have a snorkeling scuba diving trail in the center of the city, and you literally walk down steps in downtown Wellington and get into the water and go see really incredible things living right there in the Inner Harbor. Victoria Gasteiz in the Basque Country has done these amazing projects of creating a series of concentric rings of parks and greenways, and then also then interconnecting through them of bringing buried streams back up to the surface to create linear greenways that way, and also convey more stormwater than a buried culvert will ever carry. So we're seeing really incredible stuff going on in cities all over the world.
It's utopia. I love that.
I mean, the Wellington example, it begs the question, right? Why can't other cities be like Wellington, where you can live there, work there, and experience nature, and it's not polluted, right? Because there's a lack of pollution in the Wellington Harbour, right? To the point where you can go down there and go goggling or scuba diving, right? That's freaking insane. Most cities are so far from that, you can't even see the light from that, right? It's that far away. But that has to be an aspiration, right? If you're a city planner, that's super aspirational. And the question is, why not?
So there were I don't know if you guys know Kenneth Boulding. He was an amazing economist. He was one of the folks who put forward steady state theory for sustainable economies. He worked on the Manhattan Project. Kenneth had this amazing comment. He says, "What exists is possible."
That is awesome.
Right. So when we get in arguments with folks going, "No, that can't be then, that can't be, that could never be done," we roll out, "Well, it exists here."
Yeah. And that's what it takes, right? It takes the example to set it, like the 4-minute mile, right? No one broke the 4-minute mile till Roger Bannister. Then everyone broke it because it became a possible thing.
Yeah, well, look at how close we are to breaking the barrier on marathons, right? Came with less than a minute.
Yeah.
But that's not very American, that whole philosophy, right? Because my experience with America, and I have lots, I mean, I love the U.S. and I have lots of friends in the U.S., but my experience with the culture is that if it wasn't invented in the U.S., it doesn't exist.
You get that everywhere. Trust me, not invented here is not just an American phenomenon.
Oh, no, it's a
but the reality is that a lot of good things that were invented in the U.S. get exported out.
Yeah.
Deming, for example, in productivity, right? And then it's ignored for however many decades or centuries. And then someone says, "Hey, there's a great idea. Why don't we have it here in the U.S.?" Well, it actually started there.
That's a circular motion. This podcast is like a bar joke, right? A Brit, a Canadian, and an American walk into a bar.
Remember Churchill's comment about you can always count on the Americans to do the right thing after they exhausted all other possibilities.
Yeah, that's hilarious. So listen, guys, we're coming up on, we're over an hour now. We'd like to keep things to an hour, but we've got some quick fire questions we want to ask you. We ask all our interviewees these questions. Now, your answer should be quite interesting given your perspective on where you are. So I'll kick it off. What advice do you have on, and this is a subject dear to my heart, what advice do you have for women in STEM and sort of moving through the built environment as a young professional?
Pick a topic that you really love and chase it to ground, and go out and find mentors.
Yes.
And not just for women, but for all engineers and designers who want to do something different and not get beat down by the system.
Yeah, here to that. Absolutely. I think, again, and my advice to anyone, young, old, in college, get a mentor. Have multiple mentors, right? I was lucky I got a good mentor when I was young. When he stopped treating me like his personal slave, it was awesome, right? But I had to go through that to show him I was in it for the long run, right? But there was a payoff. It was great. I think about him every day. Okay, Robert, do you want to take the next one?
Yeah, so we always like to hear words of advice for those graduating out of the architectural community. So if you had a few words for the architectural students, what would they be?
Take the time while you're in school to play around with biomimicry and biophilia and look at these new topics and don't be afraid to ask why.
3 whys, right? Why? Kids always go, why this, why that? Down the third one, you really get down to the answer.
Yeah, don't be afraid to ask why.
Yeah, excellent advice. So one other thing, how do you feel about I hate this term, but it's an important term, the integrated design process. So, the horizontal structure, everyone around the table, the developer, the constructor, all the engineers, the architects, the specialists, the biophilics. What's your experience been on that? I've done probably about 70 lead projects overall, and I've only seen the integrated design process done twice properly. And it was painful in that it forced a lot of work in the design that needed to be there, but it made for a better construction outcome in my experience. Have you experienced anything like that?
So we started running design charrettes on that topic in the early 90s.
Right.
And ran one of the first big environmental design charrettes done. It was for a project called the Greening the White House, and it was a 120-person charrette over the course of 3 days. 13 working teams, and led to documents that sort of mapped out strategies for that, but actually led to a lot of other projects subsequently to that. And so if they're planned well and you've got the right players at the table and the right rules for engagement, you can get really, really quite extraordinary response.
That must have been quite a high-pressure EMC task for whoever was leading that charade.
Yeah, we had a whole team of facilitators.
Right.
It took 6 months just to put together the list of participants.
I'll bet.
No politics in that, of course.
Of course. None whatsoever.
I have one question for you, Bill. Adam and I have talked about this with other guests on the show, and that is the terminology that we use and how it gets destroyed and watered down, and it ultimately loses its ethos. How do we prevent the word biophilia from losing its soul? Sustainability is gone. Green's gone. None of these things have any meaning anymore because industry, the marketplace, has a way of jumping on it and using it as a sales and marketing tool. How do we prevent that from happening to biophilia?
So, we're seeing a little bit of that already. Oh, great. We'll put some plants in there and we're done.
Well, in Canada, that would be a hemp or marijuana plants.
Yeah. and you're welcome, America.
It happened here first.
Why don't we have a toke on that? So one of it is really pointing out that, hey, that green wall is really fabulous. Okay, so now you've done one of 14 possible patterns. There are, and so we've been doing work and doing things where biophilic environments where there are no plants, no animals, no living things. We did work with Cliff Bar, the sports bar company, on how do you bring biophilia into a sterile industrial bakery, a 1/4-mile long building.
How do you do that?
Everything is sterile. So how do you do that? So we know that if you see a picture of nature, it will lower blood pressure and heart rate. So it lowers your stress level. If I look at that picture of nature for more than 40 seconds, I can change brain pattern as well.
Right.
Now, it's not as effective as seeing real nature, which will lower blood pressure and heart rate more, but we know that it has an impact. So Cliff Bar gets this amazing social media feed every day of, hi, I'm out on my kayak in the San Juan Islands with a Cliff Bar.
Yeah.
I'm out in the desert with my Cliff Bar.
That's cool. That is cool.
I am in the Canadian Rockies with my Cliff Bar. And so when you've got these massive white sterile walls that you can't put artwork on, or you can't even use natural materials, but you can put a projector in that space and project a photograph onto that huge metal wall, and then I can change that picture every day.
That is, that's, see, again, surprisingly simple, but goddamn effective, right?
Well, it's interesting you bring that up, Bill, because I was down at NeoCon where I saw you do your lecture, and I sat in on a well course, the Delos folks, and we were talking about stairwells and how do you change the stairwell from being a sterilized space. And on our team, we had teamwork in that course. One of the solutions that our team came up was dynamic imagery in the stairwell. Change the picture in the stairwell. And what it did is, and the whole idea was, how do we get people to use stairs more than the elevators? And it was, well, we need to create a space that people would be drawn to, that they'd want to actually use the stairs. And part of that was changing the visual stimulation in the staircases.
Or turn off the elevators.
I suppose that would be another solution.
That's the Game of Thrones approach.
Yeah, there we go. But the answer to the question is 15 requirements, and that one of the ways to prevent it from losing its soul is to hold people accountable to these 15 metrics. Is that what you're saying?
Yeah. So record what you've done, and increasingly we're doing more and more post-occupancy work of measuring and seeing how people are actually responding.
That's the high value, because as that body of knowledge builds, right, you can get some more concrete conclusions. You can point to it to clients. So that's really where the value of that research lies, I think.
Yeah. Unfortunately, it doesn't prevent people from using the term or diluting the term. And I guess ultimately, we talked about I think it was actually with John Williams, the engineer from Mexico, who's doing the airport, and we're talking about you can be right and quiet and you won't get the attraction. Or the other way of saying that is that you can be loud and wrong and you will get the attention, right?
Yeah, absolutely.
So, people using the term incorrectly or not in its fullest meaning, if they're loud, they'll drive the meaning of that term.
But even if I just do a little bit of it, I know I haven't created harm. I've created a beneficial thing. So
yeah, that's true.
Full effect? Nah, but am I getting an effect? Let's hope so.
Yeah,
it's a positive footprint in the world, right? And it's out there
Very
doing
true.
something. Yeah, I wonder how long before I get a business card that says Biophilic Commissioned Engineer.
Awesome.
Maybe soon, Adam.
Maybe soon. Okay, so I want to wrap up. Before we go, we normally put out episode notes and we let people know where they can see you and your work. Are you on Twitter? Where can people find you on social media and on the web?
So we're on LinkedIn, and you can find us on Twitter, and you can find the Terrapin Bright Green website.
Right.
Where as we learn new things, we publish white papers and put them up on the website. And so sometimes in multiple languages. So Economics of Biophilic is in English and French, and the 14 Patterns of Biophilic Design is in English, French, Spanish, and Hebrew.
Wow, got that covered. Okay, so we'll put all links up on the episode notes for people who want to follow up on that. So I got to say, this is one of my favorite podcast episodes for a couple of reasons. One, you mentioned Jacques Cousteau, so kudos for that.
Off the bat. Yeah, right off the bat.
And two, I feel I've just had... I feel I should get a CPD certificate for this. I've learned so much off this podcast. It's been ridiculous. So
it's a very powerful field of study. And there's no doubt if we had this interview 50 years from now or 100 years from now, that I think all architecture at that time would have incorporated the principles. How we fix the buildings that exist, that are sterile, very militant, penitentiary type of stuff. I don't know how we deal with those, but going forward, I think this is a field that needs to be adopted on a larger scale, no doubt.
You do it one building at a time, man. That's how you do it. Right?
One building at a time, yeah.
Okay, Bill. Thank you very much for your time. Best of luck with the book you're doing, and we'd love to have you back on when you publish that. And thank you so much. Really enjoyed it.
Yeah.
Thanks, guys.
Thank you.
Thanks. Appreciate it.
Cheers. Bye-bye.
Cheers.
Okay, Robert. Well, I don't know about you, but I feel like my brain has grown about 5% since we had that. That was awesome. I learned so much off Bill there.
Fabulous. Every once in a while, you come across somebody in the world of property development, architecture, engineering, interior design that has taken their mind and body through a journey that most of us will never, ever experience. And he's one of those guys. I mean, he sees the world from a completely different perspective, but from a perspective that most design practitioners need to adopt. No doubt in my mind, I mean, that his knowledge is one of the pieces of the puzzle that needs to be fit into the current models of design and design practice.
If you draw a line left to right, it starts off with Buckminster Fuller, Jacques Cousteau, and it ends with real world solutions in a West End hotel, right?
Yeah.
That is quite the journey, whatever way you cut that.
Yeah. Right? Yeah, absolutely. And now you know why guys like Jerry Udelson and Drew Colley and Peter Rumsey, and you look at the guys that he knows, why they have no hesitation in recommending a guy like him, because he does carry a really refreshing, enlightening view of architecture and the way we ought to design spaces. Yeah,
what surprised me was how practical what he was doing is, because when I first saw the word biophilic, it's not a term I'm very familiar with. I've heard of it. I was familiar with biomimicry, but everyone I've experienced to date has been a bit woo-woo-wee-wee with it, right? I feel like when you talk about biomimicry, we're going to form a circle and sing Kumbaya. And it's not like that. He is really doing the practical application of it in real projects, and that is the difference, right?
Yeah. I loved many of the things that he said. Ones that stick out was, well, essentially, I mean, I paraphrase it here, but work backwards from nature. So in other words, look at the carbon that a natural plot of land, take a whatever, a quarter section of land in its natural state. And what does it absorb for light? What is the carbon footprint? What is the water resource? How does that piece of land, that quarter section, fit into the land around it, from the sky to below it to the sides, the 6 sort of sides of that? And that's its natural state. So how can we use those metrics in the design of a building that would occupy that same quarter section? And if it's the same or better, then we've achieved something remarkable. As opposed to today, when someone takes a quarter section of land and they want to develop it, they rob I suppose you could say they rob the resources, but they put onto that property something that takes away from the natural elements of Earth.
It's a net. It's not a net balanced equation, right? It's a net negative for everything around it, right? Other than the in-use situation.
That one philosophy alone, if governments mandated that your development has to equal or be better than the natural state in the metrics that you define, otherwise you can't build on it, what would happen?
Oh, I know. Well, the other thing I like is the example of Wellington Harbour and Singapore. Like Singapore, you got to plant at least so many, a ratio of trees or greenery to the footprint you're taking up.
Yeah.
Right? Which is why whenever you see these architectural renderings of any new development in Singapore, they're dripping in greenery.
Right.
And that's the reason, right? And you have these interstitial spaces between towers that are green spaces. Now you know why, right? So this is why urban planning actually matters. There's two types of urban planners in the world. There's those who all they do is the tax take calculation. The ones in Toronto mostly, right?
Yeah.
A condo's going up, okay, we push the parking underground, we get so much extra property tax, awesome, you're good to go. There's not a lot of joined up thinking there about public realm and linking spaces and uses of spaces and moving people through that whole integrated town planning thing, which is why we got a waterfront here, one of the worst waterfronts in the world, right? We got this essentially, it's a continental city, not world-class city, but we got the Gotham City of Canada, right? has an underdeveloped waterfront. That is insane from a property developer's point of view because the planning's not there, right?
Yeah.
The QEW cuts right through it, and it's just ridiculous.
It's terrible. Yeah. You've lost a huge opportunity.
Yeah, and the value of that land is not realised, and then the tax isn't realised off it. And the development gains are not realised off it. There's a whole multitude of compounding things there. But
I think he said something that I know you wanted to explore. I could see it in your eyes. And that was nature doesn't do zero.
Oh, I love that. That might be the tagline for this episode, actually, by Fuller. Nature does not do zero. And that's interesting because the hot buzzword right now is net zero, right?
Yeah.
You throw a brick any direction in a building conference, then words are going to fall out of someone's mouth, right?
Yeah.
And that's considered nirvana at the moment, right?
Right.
So what's beyond that?
So, I mean, that could have been a whole episode right there.
Yeah. I might have to get someone on to defend net zero because we do give it a bit of a bash-in on a couple of episodes, right?
Well, and Lloyd Alter. Remember when we had Lloyd on, we were talking about net zero energy and particularly, single buildings like houses having photovoltaics and, the flying the banner. But one house with photovoltaics does not help the rest of society.
No.
And it has to be at a different scale and a different application. And he was right, I think Lloyd and Bill probably share a lot of the same philosophies, and it would be neat to have a roundtable discussion about that.
But that, Bill's brain, man, he's as clever as a man with 3 heads from Oxford. Right?
Yeah,
awesome.
And his understanding of the psychology and the neurosciences. People that listen to this podcast, you don't study that in your schools. Like, if you take the architects, the engineers, the interior designers, the tradespeople that listen to this program, nobody takes any courses on the neurosciences. the psychology of an environment, or the environment, how it affects your psychology or your physiology. We don't study that stuff, but the reality is it's the person that ultimately judges. And Bill's knowledge of that area is just, it's outstanding.
So he sort of confirms one of my ongoing theories about life is a Venn diagram, right? Mm. So if you've got a boring life where you're narrow-minded, you're just one circle. But how many circles overlap in his Venn diagram, right?
Yeah.
Engineering, architecture, construction, development, economics, and on it goes. Jacques Cousteau, John Denver, do you know what I mean? That guy's Venn diagram is amazing. And it overlaps. But what he does is the intersections where they all overlap, he's using them, right, in his practice.
Yeah.
That was a real lesson for me. I feel like I've just done a 1-hour training course and I feel good.
Yeah.
So that's a good place to wrap it up.
Yeah. Adam, always a pleasure, man. I love doing these things with you. They're always a learning experience for both of us. And, and if we can share what we learn with, the worldwide audience, that's just great.
Awesome, man. Me too. Okay. See you on the next one.
You've been listening to the Edifice Complex podcast with Adam Muggleton and Robert Bean. To access show notes for this episode, visit edificecomplexpodcast.com. Also, if you would like Robert or Adam to speak, teach, or consult on your project or business, please email admin@edificecomplexpodcast.com. See you next time.